Greg with 31 Events. It's Saturday, September 13th. I'm going to go through a little bit of a different workflow, and let's get going. This particular workflow is going to go to Notebook LLM by Google, and it's going to process it on an AI, particularly to generate workflow images as well as text and FAQs. So I'm going to read it verbatim. It has to be public for the AI machine for it to read the transcript. So this is going to be kind of like a walk and talk right off the slides. I apologize for it, but it is going to have to be public for the AI machine to see the transcript. So here we go. So this concept here is the organizer for the calendar invite event data is Mandy at techvader.com. She's our actor here on the left. She's loaded up all NFL games for the season onto her calendar. Her calendar is a Google Calendar. She takes those individual games that have been ingested into her personal calendar and she sends them to a command. That command is create at calendarsnack.com. Excuse me. This create at calendarsnack.com is a physical, mechanical, inbound processor for the calendar invite server. So this is the first visual that we're stabbing out or framing out, as the visual for the inbound processor for the calendar invite server. So what this visually represents is the create at calendarsnack.com routes to an email box. That email box essentially is a copy of the calendar invite to the AWS simple email service. That service is basically spelled out as a email box specific for this service. This service is called calendarsnack.com. Now, if you go out on the internet, you can go look at calendarsnack.com. That is a fully developed application using the calendar invite server technology in which we've built. The Calendar Snack app itself sits on top of the Calendar Invite server. This inbound processor for the Calendar Invite server is essentially workflow one. So the inbound processor, what it does is it takes the Calendar Invite data off of Mandy's calendar that is forwarded and copied and or sent, or the metaphors, but essentially it's a copy. As an organizer, you send it to this create at calendarsnack.com, and this email box becomes the step where the calendar invite data is disassembled and stored as a new event in the database, and then a UID is assigned to the email address of the organizer's calendar client. So essentially what this becomes is Mandy becomes a processor, if you will, by using her calendar client for create, read, update, and delete for events sent to this email box that starts the functional process of disassembling and storing the calendar invite data in the database. We assign that particular UID for that event in the database, and then we match it to the email address of the calendar the organizer's calendar client. So this attaches the organizer's email address and event UID to the calendar invite server pipeline database. So that means we do that to update or cancel the data using the organizer's calendar client if needed. So updates using the calendar client edit or save function can occur an unlimited number of times before the event invite time expires. Examples for updates are for date, time, location, or message body changes, or actually inserting promotional offers into the database for this particular event. Now, every time an edit and save are done in the calendar client of the organizer for that event, that data is sent to the email box again of the calendar invite server to be processed and stored in the database as updated. So that's essentially a update routine that's done by the organizer in the calendar client itself for that specific event that has the create at calendarsnack.com address in it. Cancel abides by the same workflow and can only be completed one time. Obviously, that data is not deleted in the calendar invite server database, but marked as canceled. So that is step one, what we call the inbound processor for the calendar invite server. So in step two, which is not linear, it could or could not be used, but metaphorically, I'm looking at it as the outbound processor for the calendar invite server. So this is a set of functions that work on the calendar invite server on AWS. And essentially, the stored calendar invite data can be called using the embedded calendar invite send API endpoint, which we've invented. This API is used for sending calendar invites in the automation use cases we have built and tested. Those are for embedding the calendar invite into RSVP buttons like MailChimp, or embedding the calendar invite into sports schedule web pages, or embedding the API, the calendar invite sending API into a GUI picker for selecting and sending calendar invites to a list using a bulk email list. Excuse me there. In all cases, the API matches the email to the UID and reassembles the calendar invite data from DynamoDB using the ETL functions we built, and sends the calendar invite out and requests a calendar receipt for that particular event. The calendar receipt is gathered from customers' calendar clients and sent back to the API gateway and stored in S3 and processed into DynamoDB for analytics and decision making. So down here in outbound processor functions for the calendar invite server, or what we call to this here in this slide is the outbound processor for the calendar invite server. API endpoint is down here, and it's essentially an abstract where we're declaring that the email address of the customer being inserted into this record here, or inserted into this URL, plus the name of the email right here, inserts here into the string, and then the UID are combined together to actually send out this particular calendar invite. So the calendar invite embed can be here visually. You'll see it here into some of the games in which we're promoting for demo only, where someone puts their email address into a box. That email is matched to the UID, and the API endpoint here, as declared in the string, hits the API gateway and then requests the UID for this particular game, and then the combination of the email address plus that game is sent in a calendar invite to the customer. So Zach at TechVader in this case here gets a calendar invite. Down here, you can use the same technique of the API number one, which is our send calendar invite endpoint under the outbound processor slide here. The visual indicates that we could embed it into the button itself for a MailChimp campaign. So this MailChimp campaign is just basically a call to action button. We actually embed the code into here. So when someone clicks it, they get a calendar invite. And then in number three, the concept of embedding the calendar invite API into a GUI for direct calendar invite sending. So the concept here is you have a large visual picker of many different, this case here was NFL games. You pick a particular game out of the picker in the visual GUI, and then you upload a email list to that to send a batch calendar invitation out to a particular football game. So those are the three concepts covered here in the outbound processor for the calendar invite server, using the send calendar invite endpoint that allows for embedded calendar invites to be sent for particular events. So what happens here is in slide number 3, which we call the update or cancel processor for the calendar invite server. This process covers the logic built in the functions that automate the sending of updated or cancel calendar invite messages from the organizer's calendar client to the inbound processor and then on to the outbound processor I just covered, if the customer has already received a calendar invite from the calendar invite sending API. So examples needed for this from a customer, or from an organizer perspective. Examples for the organizer include calendar invite data, examples for organizers include calendar invite date, time, location, or message body changes for promotional offers needed to send after the customer has first received the calendar invite. So those are done here in the calendar client for the particular event for Mandy, the organizer. And in this example here, she goes into her original game calendar for that event, and she's manipulating the data in here and using a save command, and that goes to the inbound processor to be disassembled, and then it's automatically forwarded to the outbound request processor, and then the outbound processor itself sends out the calendar invite. So I'll pick that up right here. An updated calendar invite is sent to those customers that have received the first calendar invite and have responded yes or no. So the decision logic we've determined which is best for a large community of calendar invites going out is that if someone's responded back and we've collected the calendar receipt and it is yes or maybe to the first calendar invite, the decision logic says we're going to send out the updated calendar invite. If they have not responded or have said no, obviously we're not going to update the calendar invitation already sent to them. Now, for those people that are in this decision logic, calendar receipts are requested again and sent back to the API gateway, and we do collect yes, no, and maybe responses from the newly updated calendar invite that has gone out. This process is automated and actually requires no approval. So if I just stay here and kind of refresh the thought process for the update or cancel processor for the calendar invite server, this decision logic covers the logic for the built-in functions. These built-in functions are for update or calendar invite messages sent from the organizer's calendar client. Those flow to the inbound and on to the outbound processor if the customer has already received a calendar invite from one of the calendar invite sending API. So I'll pick it up down here, which is when the event is canceled from the organizer in the calendar client, the canceled calendar invite is sent to the inbound processor. So this means that Mandy is sending her cancel command from her calendar client, and when she saves it, she hits cancel in her calendar client and she saves it, it's going to go to the inbound processor itself. That decision logic says let's pass it on to the outbound processor, and since that person has already received the first calendar invitation, this is going to automatically go to the inbound and outbound processor to send out the canceled calendar invite. So what happens there is that the event data is kept but tagged as canceled, and no events can be sent obviously after that. So we have a routine here in the update or cancel processor for the calendar invite server that is a bunch of functions in the background that actually handle this messaging layer for not only cancel but update. So there is a workflow switch that can be enabled that allows for a manual approval before sending out updates or canceled invites as an option in the Lambda for this function that can be wired using an API, can be wired using code to an API or to the GUI or a notification back to an email notification to the organizer. And then the organizer itself could actually allow yes or no for the updated calendar invite or the cancel calendar invite to go out. What we're finding is some of these promotions in which our customers are using the embedded calendar invite in web pages or RSVP buttons or doing batch sending in GUIs, they have a sometimes 300-400 customers downstream that accept the calendar invites, and this is kind of a crucial process, is to figure out how automatic calendar invite sending happens post a large community of people that have it on their calendars already. How would the organizer actually update that data in an automated pipeline? And that's what I just disclosed to y'all. Thanks for stopping by for a deep dive, and that'll be it for this session, and you'll see it up here on the tube, not only in this YouTube video, but you'll see a Notebook LLM explainer on it, and hopefully it does a good job. Thank you.